So, hello everyone, and thank you for coming, spending your Saturday evening here listening to me. But today I'd be talking about empowering women through astronomy citizen science. And as I progress, I'll tell you why and how. Okay, so I teach at the Maulana Azad National Urdu University. This is in Hyderabad. I teach physics and astronomy, and that's my email. You can always get in touch with me if you would like to, if you have some queries or something to discuss. So, astronomy is essentially a technology driven science. Okay. So, it basically requires very specialized skills. You use very expensive equipment to actually use it. And therefore, it's generally difficult for citizens to comprehend if you start talking about normal astronomy jargon. You know, the terms which we have in astronomy and the kind of things we do, it obviously becomes difficult for people to understand, citizens to understand. However, astronomy is unique in the sense it is a science which has a universal appeal. Anybody, if you talk to them about astronomy, they'll definitely tell you, oh, I love it. It's so interesting. It's so nice. It's so good. And therefore, astronomy, though it is, it is technology driven, it's a hard science in the sense it basically involves a lot of maths and physics, but it is the one science which can be very easily used to actually connect with citizens, that is with non-scientists, for the simple reason that it has this appeal to everyone. Now, women have obviously always been interested in astronomy, but a lot of the women, most of them, have been unsung heroes. So I have a picture of you, a few of them. We don't have the time to talk about them in detail, but you do have quite a few of them who have been not been given credit for the kind of work they did for various reasons. And you can actually see that if you are there are some of these women astronomers who are there in this picture. I will not go into the details, but they have been very important. They've played very important roles in actually making history in very important astronomical discoveries for very important milestones. But for unfortunate reasons, various reasons, a lot of these women have not been given credit for the work they did and recognized. Even back home, we know that even ISRO, Indian Space Research Organization, has a lot of women over there. And many of these women are what are called, the project leaders and the project managers. You can see Nandini Harinath. This is Sita Somasundaram, who was in charge for Astrosat. You have Nanal Rohit, who was in charge for the methane sensor for Mars. And a lot of women who have been active in that. So this is really very nice because you'll see a lot of ISRO posts where they do feature their women. They try to project the role women have played in ISRO's endeavors. But if you actually see the biggest, what do you say, the biggest group of astronomers is called the International Astronomical Union. If you see that in the International Astronomical Union in the 1930s, the 1940s, the female percentage in membership was barely 10%. And in today's times, it's not that it's improved so much, it's barely gone up to 20%. Okay. So it's even now at present times in the International Astronomical Union, women are only 20%. However, if you were to make a break in terms of age groups, you'd see that for the younger generation, you have a slightly better representation of women. About 35 to 40% of younger generation members are women, but we still don't have a 50-50, right? And obviously, the capabilities of women are beyond doubt. There's no argument about it. But if you actually see IU membership, even for India, for US, China, you still have small numbers. And basically, what happens is very similar to what happens in physics, that this is called the scissor diagram. That, for example, when you start off with high school students interested in maths and physics, you can see that you may have still a male domination, say 65% of them doing are males and 45% are females. But as you progress ahead, as you go in for bachelor's degrees and PhD degrees, and then to assistant professors, associate professors, full professors, you can see that the number of women falls very sharply. So you barely have 5% women as full professors and like 95% men as full professors. So there is definitely a very big problem. If you actually see the same diagram over here, you can see at graduate school level, you may have a better breakup in male female. But as you go to full professors, you can see that there's clearly a very strong dominance of men and there's a clear lack of women at higher positions. Even if you actually see it, this is for the US, if you were to take the population, the white male population is about 31%, white female is 32%, Asian males, etc. You can see it over here. But when it comes to jobs in sciences, you can see 50% are white male, 18% are white female, and then you have a very few very few bad representation of the rest of the groups, right? There's also what is called the two body problem, that often women in astronomy, they marry astronomers, and then when they look for jobs, they do not get appointments together in the same place, due to which often the male gets a job and the female doesn't get the job. She's generally senior, and she may not be considered for the job because the employers may think if we take two people it'll be a problem, and they avoid it. And there are obviously many issues on why is this for women. One important thing is the stereotypes. Society itself has their stereotypes in their minds as to what women should be doing and what are the kind of professions they should take up. So that's why even young girls are groomed and told that they should not do certain professions, while young boys are encouraged to do maths and sciences, while girls and women are generally encouraged to do other things. So the idea is to basically a three-step process. One is about educating women. The other thing is about ensuring that recruitment takes place for women on equal stands. Then the other important this thing is about retaining the women force, because generally women, by the time they get their jobs, they may have other issues, they may start families, they may have other issues, may have it difficult to stay in their jobs. So something has to be done very clearly to retain them, to help them stay on with their jobs. And there has to be an overall sensitization, gender sensitization at workplaces. Now, so in short, that is the scene of women in astronomy, where you can see they are clearly underrepresented. And a lot of the problem, like I said, is even societal because of the stereotypes as well as how things move. Now, citizen science. Today, we are going to be basically focusing on citizen science. What does citizen science do? What's the beauty of citizen science? The first thing is that it lets people access and contribute to science, right? They actually can become a part of the larger community of scientists because they can see what is it that scientists are working on and involve themselves into some part of their activities. Another important part of citizen science is it actually shows people the scientific method. What is the scientific method? In the sense, how do we make actual observations in the scientific method? How do we develop our theories to match our observations? And then how do we actually even re-look at our theories if we have contradictory observations, right? That's the scientific method. And basically, citizen science projects, if you see them, they basically give people an opportunity to actually see these observations, see how they are used to make hypotheses as well as discover theories, and then how that they developed. Citizen science can also be used to remove superstitions and misconceptions in society. It's shocking that even to date, people do have restrictions. For example, at looking at the eclipse, they think they should not look at the eclipse, or they should not eat food while the eclipse is on, or that the eclipse is an indicator of all kinds of other things. Um, on the day of the eclipse, which happened recently on 8th of April in the US, I was part of one of the news channels where they were actually trying to say that, oh, the eclipse is going to have its effects even in India because of whatever reasons, which is obviously absurd. But if you actually involve people in the scientific method, hopefully they should not believe in such superstitions. So it helps actually spread awareness. Now, for a certain generation of people who may be involved in citizen science, they may just do it as a hobby, but some of them can actually, it could be their first exposure into taking up astronomy as a career. They may actually see how can they consider astronomy as a career. It's also gratifying at a personal level if you are not, even if you just get involved. And in a way, it can actually empower women. Specifically, because in citizen science projects, what happens is you need not know the technical details, right? Because it's meant for people who do not know the technical details. And often you could have many people, including women as well as men, who would like to do some citizen science projects in astronomy, would try to study astronomy, for example, but they do not know the technical jargon, right? They do not know how to write Python code. They do not know physics. They do not know any mathematical equations. So they cannot do things of that kind. So citizen science projects actually enables people to participate without actually having a technical background, right? That's the basic purpose. And Specifically for astronomy, it works out very well because in astronomy, there are so many interesting objects to observe that, in principle, professional astronomers do not suffice for the amount of data we have, right? So we have a lot of data from various telescopes, from various missions, various projects, and the community of astronomers is not sufficient to actually even look at the data. So when we talk about some of the projects, you'll see, I'll show you how citizen science are actually looking at the data which professional astronomers, they're not enough of them to actually look at the data, so they are kind of helping build the subject because they are contributing in that sense. So, I also believe that citizen science in astronomy or in science itself is very important because we know that scientific temper is necessary in societies, right? Otherwise, see, the purpose of citizen scientists is not to make everybody a professional astronomer, right? You do not have to become a professional astronomer. But what is very important for society is that there has to be scientific temper, right? People should have a scientific temper so that when they face certain issues, right? For example, we saw when the pandemic took place, almost all countries and everybody handled it in the most unscientific manner, right? While if you have a proper scientific temper in people, it would be much more easier to actually solve such problems, right? So scientific temper is definitely necessary. Superstitions, for example, about eclipses, etc., should not be there. Misconceptions. You'd be surprised to know that actually there's a group of people who actually still believe that the Earth is flat. Okay, and there are you can actually Google it and see there are many interesting things about what the flat earthers try to do, and why do they believe that the rest of the scientific community is actually uh, you know f- uh, you know giving them the wrong impression, and that the flat earthers think of themselves as very right, right? So you still have a lot of misconceptions in societies. This is not only India, this refers to the whole world, where you still have a lot of misconceptions. And if scientific temper is got into the people, right, through these citizen science projects, then it can actually help in resolving these issues. Now, the fun part about citizen science is that, for example, I'll talk to you about there's a project which is called asteroid hunting. So, what if you could get an asteroid named after you, right? So, it could be fun, right? You actually look for asteroids, and if you actually find one, an asteroid could be named after you. You could also have a new class of galaxies identified by you because there is one project in which people actually look at galaxy morphologies, and they try to see if they try to see the different morphologies of galaxies, and you're going through millions of images, and there is a chance that you may get a certain morphology which people may have not even seen before this. There are also some citizen science projects which are involved in exoplanet searching. You're actually looking for exoplanets, and these also play a very important role because, for example, the James Webb Space Telescope, which you must have heard about, it's a big telescope, right? 6.4-meter telescope. And what it basically needs, it needs input. For example, if you're looking at exoplanets, somebody has to actually do the homework before that so that you actually look for candidates which are interesting, for example, for James Webb. And that can be only done with smaller telescopes when people actually look at other data through smaller telescopes. And based on that, they shortlist potential good candidates for James Webb to look at, right? Because James Webb cannot do a blind searching, right? You have to actually look for concrete targets or candidates that can be interesting for James Webb. So there are even some citizen science projects where you actually look for exoplanets, and you actually try to see if what kinds are there, and help to build up what do you say, observation candidates for example, James Webb or even other big telescopes. So let's now see some examples of what are the kind of citizen science projects this thing. So I'll start off with Sovan Acharya sir, his essay Citizen Science, which many of you all may be aware of. And basically, he has initiated this group where basically you have students from schools, colleges, where teachers and students, they can participate in various citizen science projects all around the world, encourage others to participate. And it's very important because number one, it gives people knowledge about astronomical events. about things like occultations, eclipses, various things which are happening. Now, there's a WhatsApp group. You could all become members of that. And you can see that with that, you can actually have interaction between different teams, different groups which are working on this thing. It's a zero funding project. You do not require funding for this. It can increase the scientific temperament between teachers and students. Students can prepare future participants. You can help for Olympiads and things like that. It could help them gain knowledge about the universe, mental peace, and no movement required. You just need digital media. Okay. So there are various such these things. So that's his thing. I will now talk about some of the more ones in detail. For example, NASA, if you actually see, they have a citizen science this thing. I'll show you the website. Here is the website. So NASA actually has a website. I hope you can see my screen, right? All good, right? Can you see it?
Yes, madam.
Yeah. Okay, because I'm sharing the whole screen. Yeah. So if you actually Google, you can actually search NASA Citizen Science, and you can see that there are various citizen science projects which are proposed by NASA itself. For example, there's one called Escape Soundscapes, which is anyone with access to a computer can. So many of these require access to a computer, and some of them do not even need computers. You can just use it using a cell phone. For example, if you see this project, this is called Globe Eclipse Project. You can go to the project website. And what you need for this is just a cell phone and a thermometer, right? So, what do you do in this project? You can see over here what is Globe Eclipse. In this thing, it's a temporary tool in Globe Observer, which is details about this thing. It is not visible in the app, this thing, but for example, it opens up when there's a solar eclipse. Recently, you had a solar eclipse in the US on the 8th of April. So, typically at that time, what people could do is that they were encouraged to use this to take the air temperature measurements using a thermometer, as well as taking regular observational sky conditions using another tool called the clouds tool and a land cover tool. And you could actually take this data for the eclipse, right? So typically here you see this is for the 8th of April eclipse, which took place very recently in the US. And what people did is that you had all these different stations, and people could contribute with their data, with their observations which they got for all these places. And with that, you could actually, why are your observations important? You can see this over there. You know that basically we depend on the sun for our energy. But what happens when there's an eclipse, right? Like I said, that people have a lot of misconceptions and lots of superstitions that in an eclipse, because the sun, the sunlight doesn't reach you, strange things will happen. But actually, here what happens is you actually take different readings to see the atmospheric conditions as well as surface conditions and see the impact it has, compare data for different places, and you can actually this. So this is what people actually did with the tool, where they could, observe the eclipse in a, in a collective way, right? So people all through the track of that eclipse, if you see the track of the eclipse was all over US, North America, and part of Canada. So all these people could actually, and Mexico over here. So you can see that all these people could contribute to the kind of data which was available about the eclipse. That's a recent one. So this is for the eclipse, but there could be various other things. For example, there's a very interesting NASA telescope which is out in space called the TESS telescope. Now, what the TESS telescope basically does is it basically is looking for exoplanets. What is an exoplanet? An exoplanet is a planet outside our solar system, okay, which does not include our planets, but planets outside our solar system. Now, how does TESS do the observations? Okay, so TESS is a telescope out in space. Now, what it basically does is it observes what are called transits. What is a transit? That supposing if I have a star and I have a planet going in front of it, then what is going to happen? The light from the star will fall, right? The brightness, when the planet comes in front of it, the brightness of the star would fall, and then as the planet goes behind, again the brightness will become as it was, right? So that is what is called a transit, okay, when the planet comes in front of this. Now, obviously, when TESS is taking its data, TESS is almost scanning the whole sky, and it keeps observing, okay? So what happens is, as it keeps observing, there are so many stars it actually observes, for which it finds what is called its light curve. By light curve, we mean the change in brightness with time. So that means intensity versus time. So typically, if you have a transit over here, you'll see a fall like this, and you look at this, you have a series of falls coming over here. So you can actually see, find the period, right? Because this is happening because the planet is coming in front of the star. So you are getting all these transits over here, right? Now, obviously, so what test does, which is, it's basically, its job is just to observe transits. So what it does is it keeps looking at stars and sees their light curves. How does the light curve change? Okay, so you'll typically have a drop if you have a planet. Obviously, you can have a drop for many other reasons also, other than the presence of a planet. The sun could have sunspots, the sun could be part of the star could be part of a binary. There could be various other reasons why the star is actually, why does it varying in time. You could have other reasons. But uh, you we are looking, what tess has done is it's basically looking for exoplanets. And therefore what happens is that you can actually look at individual light curves, right? So all the light curves are available. You can actually look for individual light curves, and you can actually trace whether you think that there's a planet or no. And while you join the thing, it kind of gives you the training which you require so that you can identify it. And this is very, very important for the simple reason that the amount of data which we are getting from tests, it is impossible for the astronomy community to actually look at all that data. It's too much of data, it's almost the whole sky, and it's too many light curves. So what astronomers do basically is they write code. Okay, so in an automated fashion, you actually check the light curves of stars and check which ones have planets. But we do not have the time to look at individual objects, right? Unless and until there is a reason to look at some individual object, we actually have to just look at the whole set of it. So something can actually get missed, right? There could be some special cases because it's very complicated. It's not simple because, see, for example, the sun itself has 8 planets going around it. So if you're actually looking at these exoplanets, it's not a perfect transit. If the exoplanet has 5 planets going around it, the dips are going to be different, the transits are going to be different. There are many peculiarities which could be specific for certain cases. But in this case, what happens is, as part of the citizen science project, people individually look at these light curves and they may identify something which the astronomers may not. So you can actually see over here there are 43,000, so many volunteers who have actually volunteered to contribute to these this data. They have done 175,000 classifications. So these classifications are classifications of the light curves. So you are basically trained how can you classify based on the light curve, whether it's a planet or whether it's a eclipsing binary or whether it is sunspots, or what is the reason for the variability of the light curve, right? And therefore we need people to actually classify it and look it and complete it. So this is a very important thing, and these are the very ones which will then be then further observed by some bigger telescopes, and then finally they could even feed in for the James Webb, right? So even if you want James Webb to observe something, you may finally then use this data which you have, for example using exoplanet watch. There's also one called, there could be something even closer by. For example, if you're looking at Mars, you all know that now we have excellent data on Mars, right? The amount of rovers, etc., that are there on Mars is very, very large. Now you can actually find exotic clouds high up in the Martian atmosphere using this data. So what do? You can see again there are like 11,000, 12,000 volunteers who've already participated in this thing. And what they basically do is that they classify the kind of clouds that you have over there, and look at the surface of Mars, for which we have a lot more data, because 30 years data set, 30 data set has been completed, and using this you have this data available and one can do things like this. There's also various, there's a SETI project also. For example, look at this one. This is about looking for extraterrestrial life. And for example, for this one, you could even use a cell phone or a laptop. Either of the two can be used. And using this, you again have about 12,000 volunteers. And people, what they basically do is, you can see over that, basically the UCLA, the University of Los Angeles, the SETI program. SETI is the Search for Extraterrestrial Intelligence. And what they use is that they have a fully steerable telescope with which they are basically looking at different parts of the sky to actually look for signals coming from extraterrestrial life. Okay. So they have observed about 55,000 stars and detected over 82 million radio signals, right? 82 million. Look at that number. So obviously, it's difficult for actually somebody, astronomers or anybody to actually, check these signals. And therefore, here come in citizen scientists who can actually look at these signals. They are actually trained. So you classify the signals by matching them to common classes of radio frequency interference, and they basically do the job of classifying the signals. Once you do the classification, so you can see 12,000 volunteers have done 100,000 classifications. Then what people do is that they pick up these classified ones, and from these you select, for example, the ones which are the potential cases, and one can do further observations on those potential sources to actually look for extraterrestrial life, right? So I would encourage you all to actually literally just Google and look for NASA citizen science projects, and you can actually see these different projects, right? So this one was also for the eclipse, and you can have a look at all these other interesting projects. There are many interesting ones, and they are good to have a look at. So I'll go back to my, oops, I will go back to my presentation. 1 minute. Yeah, okay, fine. Okay, it's come back here. I'll go back, no problem. Just a minute. So this was the one which I was talking to you about, the NASA Citizen Science Project. You can have a look at these. Then there's also what is called the Zoo Universe. This is also another website. You can Google this. And if you see this thing, you will see the Zoo Universe again has a whole set of interesting citizen science projects, right? So there's one called Planet 4, which basically you explore the surface and weather of Mars, South Polar region, okay? Specifically for the South Polar region. And there are various other ones you can see, and you can see there's a whole bunch of people who've been contributing to these different projects, right, which have been there. Um, if you come back, you can actually then see, uh, yeah, there's even one which okay, I can actually, there's one citizen science project which actually does classification of galaxies also, and galaxy classification and various things like that. So I'm going to now talk to you about a few of those interesting citizen science projects. And for example, there's one interesting one which I know many of the groups over here have been involved in, which is about asteroid finding. Okay. Now, like I said, is that if you get involved in any of these projects, you will learn what is an asteroid, why do we need to find asteroids, what's happening, right? So June 20th, 30th is actually celebrated all over the world as Asteroid Day, because this marks the day on which the Siberia Tunguska event took place. So you basically had an asteroid impact which happened in Siberia in 1908, and you can see to date this region is still clear of any vegetation, etc. And we also know that, for example, the extinction of the dinosaurs also happened because a massive asteroid, which is the size of about 10 to 15 kilometers, fell down onto the earth, due to which you had the extinction of the dinosaurs. So we know that actually, even in India, there is the Lonar Lake, which is in Maharashtra. And again, this one is also a meteor crater, which actually this thing. So typically, what we know is that every day the earth is bombarded with more than 100 tons of dust and sand sized particles. About once a year, a car sized asteroid actually hits the Earth's atmosphere. Every 22,000 years or so, there is a meteor the size of a football field which actually falls onto the Earth, and it can cause some amount of damage. And once in a few million years, the object can be large enough to actually threaten Earth's civilization. And so, in short, if your space rock is smaller than about 25 meters, you don't need to worry about, because it will burn up in the atmosphere. But if it is much more heavier, much more bigger, right, then it can actually cause this thing. And therefore, it becomes very important for us to look for asteroids, right? Where do they come from? If you look at the formation of the solar system, when the solar system formed, right, you actually had, this is the protoplanetary cloud from which the sun formed. So you can see in the center you have the sun forming, and as the sun formed, you have different regions where matter actually accreted. Okay, so this accreted matter, which you can see over here, is where the planets actually formed. So you have the sun being born over here, and you can see that the planets gradually, as the sun formed and lets out its radiation, you have the clearing up of this, protoplanetary disk, which is there, the protosolar disk, and you actually have planets being formed at different regions. Okay, and you can see that it actually clears up the region between the planets, and the planets get formed. But some amount of this part is not cleared out, and if you can see, it's not too visible, but if you could see in that, there are actually regions where some amount of debris matter is still left, right? So we do have some amount of this, for example, the asteroid belt, which is between the orbits of Mars and Jupiter. And then you also have a set of these which are also beyond the orbit of Neptune. So these are basically rocky debris which is left from the time of formation of the solar system. But some of them, they have orbits in which they suddenly enter into the solar system, and they could actually come onto the earth. And this is the stuff which actually comes and falls in the earth. Now the idea is, like I said, the asteroid can actually cause a devastating effect on the earth. So what can you do? How can you protect the earth from asteroids? One way is that you actually monitor, right? You actually observe and look for asteroids which could be coming, right? Using various things, like for example, you can use a radar, or you can use telescopic data to actually look for asteroids and see, is there an asteroid coming onto us, and then what can we do to protect ourselves, right? So there is what is called the NASA Planetary Defense Coordination Office, which actually puts a list of the asteroid impacts. And the most important thing which can protect us from asteroids is early detection. Okay, not just detection, which I've written, but basically early detection. Because if you early detect it, you can probably do something to, you needn't bombard the asteroid, as long as you, supposing you even defer its path, right? Change its path, it can actually move in another direction and not cause any harm to us, right? So what do we do? So there is a citizen science project which Sovan sir has been involved in. A lot of the other people who are here in it here, Amoli Kakkar, etc., have been involved in it. And what you basically do is you use data from various telescopes. For example, the Zwicky Transient Factory or the Catalina Survey. So look at this image which you can see over here. If you look at this image, it's a set of four images, and you can see that the image is changing. All these stars are at its own position, right? The position is not changing. But you can see there's one object whose position is changing, and that is this object. Look at this object. This object is changing a lot in position. Remaining all objects are sitting in their own places, right? They are not moving because these are stars which are far away. This thing is moving so fast because it's basically close to us. Okay, so there is a software called Astron. So if you actually join in this asteroid hunting project, you can actually be part of teams. There are various teams in which you can participate. You are every day given data, and you have to basically spot in your data if you have a moving object like this one. If you have a moving object, then you do have to do some basic analysis to actually check whether this object is an asteroid. And then I participated under Sovan sir for with SA Citizen Science, where I was part of a team Arundhati. This was a team only of women. This was in 2021, and we actually looked for asteroids, right? So you basically have to install this Astrometrica software on your desktop or laptop, and you can every day when you get the data, you have to check it to look for it. And supposing if you find a good potential orbit or object, it will actually, they would actually be checked upon it. There would be more, there's the Minor Planet Center which will check upon it. And then if they realize that it is an asteroid, you would actually be given granted the honor of naming the object on approval of the International Astronomical Union, right? So that's a very important thing which can be done if you actually find an asteroid. And it's a very good fun thing to do. It was good fun doing it when I did it, right? There are also other important this thing. You can have a look over here. This is another website where I found various astronomy citizen science projects. For example, you can see this over here. I'll show that to you. You can see that you could there are other, you can actually Google and look for them. You can find various other sources. For example, studying light pollution could be also an interesting thing to do. For example, there's one other citizen science project called Planet 9, and you actually look for various undiscovered planets, dwarf stars, etc., using the data which is coming from this thing, right? There's also what is called, I hope you are all aware that nowadays, because of so many satellites being launched, right? For example, the ones, the Starlink ones launched by SpaceX, they are actually causing streaks in astronomical data. So if you have good astronomical data like this is data from Lovell Observatory in Arizona, you can see you're getting these streaks over here, which are basically being caused by satellites. Okay. And actually, people are actually doing what is called satellite track streak watcher. That means you're actually looking for the parts of satellites, because we want to monitor that well enough so that when observations are taken, we know very well where are the satellites, so that it doesn't hamper our observations. And therefore, we actually would like to you know um, check where are these things sitting, so that you can uh, look for the satellite streak watcher. There's also another thing onto tomatosphere, where you actually take some tomato seeds, expose them to conditions of outer space, plant them, and see what will happen. So you actually see how to do it. Then there's another target asteroid one, which is actually, there's a NASA spacecraft called Osiris Rex, which actually visited an asteroid called Bennu, and now they're looking for more asteroid travel destinations. And so if you have a telescope, an 8-inch telescope or a larger telescope, you can actually look for various asteroids which are there in our neighborhood, and look for other good targets which can be used. There's also something called spiral graph, which is an interesting thing. It allows you to actually trace the shape of the spiral galaxy arms, helping astronomers get a good idea of this thing. So even if you can barely identify the Big Dipper, you can actually can ID properties of galaxies, etc. So this is another one. Another interesting one which people do is called globe of night. Another big problem which is there in astronomy is the problem of light pollution. There's a lot of light pollution which is actually spoiling all our dark skies, which is something which astronomers are really very worried about, because nowadays dark sites are considered heritage sites which have to be preserved, because we are now already seeing that on the earth you have very limited amount of dark skies, right? So they have to be preserved, and things have to be done to ensure that dark skies are there. And therefore what they do is they are basically monitoring light pollution. So for different locations, you actually, your job is, you basically look up at the sky, right? And you identify constellations, and you identify which of the stars of those constellations you can observe. Okay. Now this is very easy to do. Here I have a smartphone, and if you're on your smartphone, you even have, for example, the Stellarium app. Okay. This is the Stellarium app. You can actually use that, place it on the, place it in the sky, use that to identify constellations, right? Look at which constellations you can identify, and see which of the stars in those constellations you can identify. Now we know the brightness of these different stars, right, in different constellations. And therefore, for example, if you tell me, for example, in Big Dipper, you can identify, say, three of the stars. I know the brightness of the stars, so I can estimate what is your sky brightness based on the number of stars you can observe. So all you need to do is have a Stellarium app or a Google Sky app, something like that. Look up at the sky, see, identify any constellations, and see which are the stars of those constellations you can observe with your naked eye, right? So that will tell me what is the brightness of the sky and what is the sky quality, right? So this is being done to monitor the sky quality in different regions, right? So I will go here. Okay. So that was the one which I was showing you about. Now, okay, yeah. So I am not talking too much about. I just told you a little bit about zoo, universe, etc. But there are various citizen science projects. So we don't have the time today, but I would encourage you to have a look at those websites where I was talking about, where you can see these various citizen science projects. Like I told you, it could be even looking for supernovae. There are projects in which you're basically looking for transient stars. That means a change in brightness in a star. And when you look for that, you may actually find supernovae and various objects. So you can look for supernovae, you can look for exoplanets, you can look for asteroids, you can actually monitor the night sky brightness, you can look for satellite streaks. There are many, many ways in which you can contribute. Now, many of these people who are actually doing citizen science projects, for example, if you helped in build up a candidate list, for example, for observations for James Webb Telescope, right? Then actually your contribution is actually acknowledged, right? So you could actually be made a co-author in a paper, or the paper could mention that you were one of the persons who actually helped shortlist which are the exoplanets which can be observed, etc., and do things like that. So now, towards the end, I would just like to talk. In 2021, we actually did a whole series on citizen science. I will show you the link to those things where individual projects were discussed in more detail, and that's when I made a few good friends. So I'll start off with a good friend who's also attending today. This is Amoli, and what we had, you can see that this is we had these various what do you say sessions on citizen science projects, and here I met Amoli. Amoli is also attending today. And Amoli actually got involved in, for example, these asteroid projects. So when I actually joined the asteroid project under Sovanacharya sir, which I just showed you the certificate of, Amoli was actually one of the trainers. So actually, she was even training me on how do you actually look at the data using Astrometrica so that you can identify potential asteroids, right? And how do you actually go get involved in it? So you can see that it's not just our session which we had, but Amoli has actually presented her work in various different sessions. I found some of these on the net, but there are many more where she's actually done workshops or actually described in detail how citizen scientists, for example, can contribute to the asteroid search campaign. And like I told you, an asteroid search campaign, it's actually a question of life and death in principle. So actually looking for asteroids is something very, very important. And Amoli has been very involved in it. And I'm sure she's really enjoyed doing that because she's still doing it. Right?
Absolutely, ma'am.
Yeah, that's
Thank you.
why I
Thank
thought I
you.
should talk about
Thank
it.
you so much for acknowledging my work.
No, no, it's very good work. It's very good. And that's a perfect example, is like what we actually talking about is that about women being involved with citizen science projects. So, for example, in your case, if you getting into hardcore astronomy is difficult because, like I said, there's a lot of technical jargon and you need training in physics, maths, etc. But for example, in something like this, which is really very crucial, it is protecting the earth, you're protecting the planet itself, then obviously it's very important these kind of projects. And you don't know, someday you may actually get something which is really very seriously vital for us, right? We don't know, right?
Sure,
So
sure.
that's really good work you're doing. Another
Thank
good
you, ma'am.
example, another friend I met when we were doing these sessions was Sona Shukla. Sona Shukla actually, this is not a citizen science project, but Sona Shukla actually got interested in astrophotography, right? And she's a mother of two teenage kids. She lives in Delhi. She's an entrepreneur by itself, but she actually started doing astrophotography. And the interesting thing is she started doing it with a smartphone, okay? But later on it was such, so I mean, she enjoyed it so much that later on she actually moved on to getting a dedicated camera and things like that. So you can actually have a look at her website. She has a website, and you can actually see a lot of the pictures, etc., that she has taken, which I can show you over here. um, yeah, this place doesn't have that, but you can see that there are a whole bunch of, these are some very beautiful images which are taken by Sona Shukla, and some of them were actually taken up by even the Astronomy magazine, Sky and Telescope, etc. You can see these. She won a few prizes. You can see here she's winner for the eclipse on Jupiter. I hope you are aware that solar eclipses happen here, but you actually have eclipses happening on planets also. So you have an eclipse happening over here with Jupiter, and she actually got a prize for her image which she got of Jupiter. And you can see that there are various other very beautiful images. which she got.
And she's basically a planetary astrophotographer.
Yeah, yeah. But so it's not, but it is kind of citizen science because you can.
Definitely, ma'am. Definitely. When
Yeah,
we observe Jupiter on a regular basis and you see the red spot every 10 hours, and if you find the moons of Jupiter making an eclipse on it, so
yeah,
that's really fascinating. And trying to follow it and clicking it
yeah,
on
yeah, yeah.
time
So it does take a,
is,
I mean, it's not very easy taking such images. It takes a lot of
yeah,
effort. And the best part about Sona's pictures, what I find is that she's doing it in Delhi. And Delhi is
yes,
known for bad skies and pathetic
yes,
conditions, right? And in spite of that, you can see the kind of images which she got are really very beautiful. They're really, really very beautiful
absolutely.
and very nice. And so you can have a look at her pictures and actually see, and she totally enjoys it. It's real a fun thing, and something which so this was again when we did our sessions. And then another friend, young friend I made at that time was when we were doing these citizen. This is Kushi Arora. Okay. And Kushi Arora is a young girl, and you can see her things from here. She started off doing citizen science things, but then she actually started getting involved in working also with it. You can see she's actually doing her BSc in Chandigarh, and along with this, she started doing a lot of other things, volunteering for various things. And a lot of the projects she was doing were she was actually doing it just on her smartphone. And what I found most interesting when I spoke to Khushi when we did these sessions, see, these were done kind of COVID, post COVID, during that time, during the pandemic. And Khushi's told me something very interesting, which she actually said that during the pandemic time, we know that amongst the most affected people by the pandemic were young children, right? Older people are quite used to sitting at home, and they were not so disturbed about restrictions. But typically, young children, teenagers especially, and even young children, they could not go out of their homes, right? They were stuck in their homes. They could not interact with their friends because, for example, everybody had somebody old at home who had to be protected, and hence you could not, risk their lives. And you. So Kushi actually told me, which I also know from a lot of people, that a lot of youngsters during the pandemic, they actually had psychological problems. Many of them actually went for therapy. A good chunk of young children actually had to get therapy, or go to psychiatrists or psychologists because of the amount of psychological problems they faced during the pandemic. And Kushi told me that she did not have any such problem because she got involved in these citizen science projects which she was basically doing on her phone. And she said, like, well, all my other friends were actually so harassed about the pandemic and not getting a chance to go out and not getting a chance to meet. She said, I was so involved doing these things that I was actually super busy. And so you can see what I have this scene over right over here. You can see there's a project called Supernova Hunter, and she actually discovered 139 supernovas. Okay, she actually found 49 preliminary asteroids, and she did two provisional asteroids. She was also part of many space projects and got involved in many things. For example, science communication, social media management, various things. And so Kushi told me something which I was really happy about, where she actually told me that doing these citizen science projects actually helped her keep up her mental health during the pandemic. Okay, and now when everybody is so aware about mental health and mental health issues, I mean, I had never realized it that doing these things could actually be important in something like this also, right? Because it actually makes you feel useful, right? Obviously, you're going to be thrilled if you're going to be discovering 139 supernovae, for example, right? And you can actually Google and see, because she has actually then participated in a lot of online webinars and presented her things and her work. And so it actually you can see it's actually affected her life, touched upon her life very strongly. So different people, you, like I said, you could be doing citizen science things just as a hobby. You could actually, it could, or it could even be something which could help frame your career. So Khushi is still young, so probably it may help frame her career. But let's see, it could play an important role in that. And then another friend I met during these citizen science projects, many of you all may know, this is Dr. Mila Mitra. She's actually got her PhD. But now what she does is she has this thing called STEM in Space. And basically, what they are trying to do is they're trying to involve school children. You can again have a look at the website over here, which I have linked over here, and you can see that they basically run something called STEM and Space. And what they do is that they also do asteroid hunting, in the sense they make these groups, like even Sovan sir does, where you actually do asteroid hunting, and you do a whole set of things where you can actually get school children involved in many of these citizen science projects as well. And you can actually see they have actually done various things using this, right? So that's Miller. So I would like to conclude over here that, like I said, being involved in citizen science projects is very important for encouraging scientific temper, right? And getting people aware. For example, if you're enrolled in asteroid hunting, you will understand what is an asteroid, what is the threat of asteroids, or you may see what are exoplanets, why are we looking for exoplanets, or you may discover what are supernovae, what is so special about supernovae, or you may actually take readings during a solar eclipse and see how do the conditions change when a solar eclipse is taking place, right? So it gives you a lot of exposure to scientific activity, scientific awareness, puts you involved in the thing. And like I said, in some cases it may just be a hobby for people, which is also fine. And in some cases it may actually help mold their careers, right? Depending upon how involved they get into these citizen science projects. But it at least gives you a first hand exposure or a chance to actually deal with astronomy data, right? Because you are actually seeing data, astronomy data, and you can see how can it be used. And in today's time, I think that what we actually would wish for is a world where everybody has a freedom of choice, right? Irrespective of your gender, whether you're male or female or whatever. If you are interested in a certain subject, it could be astronomy, it could be anything, everybody should have a freedom of choice, should have equal opportunity. I would also like to talk about what I often recommend is we don't require any reservation. We should ideally have a position where women can do astronomy without any reservation. They can win basically just based on their merit, right? The individual is non gender. After all, other than reproductive organs, everything is the same. So, ideally speaking, these women should also, women, men, I don't have anything against men. So even women, men, everybody can be can get a glimpse of what astronomy is all about, what is the kind of research or work that we do using these kind of projects, and have a look at it. So I would encourage you all. I'm sorry, this is, you take it as self propaganda, but I would just like to show this to you because what we did is we did about 10 videos. This was, I think, in 2021, where we actually did a whole set of videos on a guide to citizen science projects, where you can actually see that there was a session done specifically on astrophotography. There are other people over here, men, so I didn't mention them today, but you had Amit Raka, Somit Mukherjee is also here, and we had people spoke about different citizen science projects. So if you want more details on astrophotography, or, for example, on the Zoo Universe project, we had Stella Kafka, Sovan Acharya, Ashok Ghosh, various people who spoke about that. We had Bonnie Thurber, who spoke about another citizen science project, which is called Moon Over Us. Very interesting project. Have a look at it. We had Gaurav Banerjee, who spoke about Spectra Police, basically studying spectroscopy. We had Stella Kafka, who spoke about citizen science projects again. We had Amoli Khushi, Teja Begari, who spoke about other citizen science projects, Mila Mitra, Amoli, etc., who spoke about that, astrophotography with telescopes. We also had stuff about astrophotography using cell phones, and then women and girls' participation with astronomy archival data. So I would encourage you to have a look at these various videos where you can actually see more details on individual citizen science projects, right? So I'd like to end with this, and I'd be happy to take questions. Yeah.
Lovely presentation and lovely talk about the citizen science projects. Really, it gives an insight to a layman that how a citizen science project can change your thinking and
Hmm.
bring joy in your life sitting at home. You are
Yeah.
not bothered about your mundane routine or mundane things which you are doing, but it takes you to another level. It actually gives me peace of mind.
Oh, great. That is so nice to know. That,
Yeah,
and like I'm saying now, like what I said about Khushi's thing is that I had never realized that astronomy can play a role even in mental health. You know.
it definitely does, ma'am.
Yeah.
Whenever you are stressed or whenever you are tired of your whole day activity, at night, if you just open your cell phone and try to do some of the citizen science projects, which you can do it on the cell phone or maybe a laptop,
Yeah.
it really relieves you from the stress and the tiredness of the whole day.
Yeah.
I feel so.
No, like they say in Urdu, right? और भी गम है जमाने में मोहब्बत के सिवा.
Definitely,
You
definitely.
actually open your eyes to the bigger picture, the bigger world, and
Yeah.
stop thinking of your small little universe, and you get on to, yeah.
And ma'am, we should not forget that Sovan sir is a person who has brought many of us together in the citizen
Yes,
science projects.
yes,
He
yes. That's why
is one
I
of the
started off with
pioneers.
him only, right? I started off the this thing with his
Yeah,
group.
yeah,
Yeah, I think it's a very important thing he's doing. It's a very encouraging thing, and it has brought a
definitely,
lot of people
definitely.
together. Yeah, I think that's really very nice. That's
Yeah,
uh, and like I'm saying, right, all the friends I made when we did those webinars, it was good fun doing it.
definitely.